I want to spray paint with molten metal. I know it's possible, but the machines that do it the way that I want to do it are somewhere in the 5-figure range, and I don't have that kind of money. So we're going to see if it's remotely possible to do it at home on a very limited budget. So if it wasn't already painfully obvious, this is very much so a proof of concept. It's not going to be pretty, but hopefully it will show us if this is remotely possible and teach us what kind of issues we can expect and avoid on future iterations in potentially a future video. So how is this supposed to work? So we have two wire feeders, two spools of wire, and two nozzles. One nozzle is positive, one is negative. So when the wires touch in the middle, they arc, they melt, and then our air compressor will blow that molten metal out and, in theory, spray it onto our piece. Is that how it's actually going to play out? I don't know. We'll see. So stick welding didn't make a continuous arc. So I've got my TIG welder here, and I'm just going to manually start the arc, and maybe that will not do that. I mean, it's not working. Alright, one more quick try with some more pressure. So there is more metal on there than there was before. It's not pretty, and I think we have two main issues to address here. One is that my pressure was too low, only maybe 20 or 30 psi, so we're not getting good atomization. That's fine, I can crank that up. The bigger issue is that it's feeding the wire too fast for my welder to melt it. The welder's on the max setting. I have the wire feeders going as slow as they can go with my current setup, and we're still getting large section of wire that are not melted. So I need to figure out a way to slow down those feeders even more. So definitely better, but still pretty splotchy. We're gonna see if we can crank this pressure higher to get better atomization. So I've been controlling the wire feed rate with this power supply. It goes from 4 to 12 volts, and when that was still too fast, I added the resistors, and that helped a little bit, but at some point when you drop the voltage too much with a DC motor, it just becomes inconsistent. So we got a PWM controller, and what this does is instead of changing the voltage, it will send the full 12 volts in pulses, and depending on how long those pulses are, dictates how fast the motor spins. So hopefully this should give us a more precise control of the feed rate at lower speeds. So that is by far our best result yet. The particles are pretty small, they're pretty even, but I think we can go even smaller. So one issue we're having is that the air compressor just can't keep up. We're using too much air and it drops pressure over time. The other issue is you want to increase our air velocity so that we can get better atomization. I think we can achieve both of those things by making a smaller nozzle for the air gun. So even better yet, with the nozzle, we have generally smaller particles except for a couple blobs. I think that's probably just because I have a cheap welder that's not making a consistent arc. So there's nothing we can do about that right now. So we're going to move on and make a shield around our nozzle out of this aluminum. That way I can't see the arc directly and I can get away with just wearing some torch glasses. And then I can wear a proper respirator because I really don't want to be breathing some of these metals that I plan on spraying next. We're going to mount our PWM controller properly. We're going to put a larger knob on it so I can control it better. And then we're going to see if we can spray some aluminum instead of the steel. That went down a lot better than I thought it would. It sprayed about the same as steel. I could feed it a little bit faster because it has a lower melting point. The main difference is steel on steel, the adhesion is really bad. But aluminum on steel, it's not coming off. I don't think I even got through the aluminum on any of that. So this is going to be really good for protecting my steel parts from corrosion. So these tips I made just kind of suck. They work okay with steel wire, but the aluminum wire is a lot softer. So it ends up doing that. So I went out and I grabbed some MIG welding tips to see if we can fit on there. So that is much easier to feed the wire. It shouldn't jam up, and now we have much more consistent contact between the wires. So this welder does stick and TIG. I've been running it in TIG and just manually triggering it with the handpiece. But we're going to see if we can run it in stick and see if it will automatically start the arc when the wires touch. These tubes also just kind of suck, so I ordered some much smaller diameter Teflon tubes that are going to run to a spool box so our wires aren't touching and shorting out to each other all the time. So now we have two spools with a spring in between them, which pushes against some foam discs on the end. That just gives it a little bit of resistance so they don't unspool themselves. I also lined the inside of the copper tube all the way up to the feeder to make sure it doesn't jam up. So now we should have no issues feeding our wire. So we know the plates we spray stay pretty cool immediately after spraying them. So the question is, can you spray a 3D print? Now the only 3D print I have is this incredibly heartfelt gift from my brother-in-law. So we're going to see if we can turn this guy into aluminum.
Is this a good listening experience? I put my microphone inside my mask. It's sticking out a little bit, but not as much as I would hope. That actually is starting to stick. It doesn't seem to be melting him at all.
Well, it didn't want to stick at first, but once it starts sticking, it can build on top of itself pretty quickly. Obviously, if I had the patience to, I could polish it all up. You probably want to build it up a little bit thicker than I did so you don't blow through it. But I think the proof of concept has been proven. Now I want to test a real world application for this, and this is my coal forge. Now the top doesn't get very rusty, but for some reason the bottom gets very rusty. So we're going to clean this up and see if we can spray some aluminum on it. That went really well. Everything's really smooth. Anywhere that I have any adhesion issues is just because I didn't grind it well enough. But the working temperature of an aluminum coating like this should be just within the working temperature of the forge. So this should last a really long time. Let me know in the comments if you guys have any other ideas of what else I could do with this. Please like and subscribe, and I'll see you in the next one.